Today we're going to look at some similar triangle word problems. And kind of with that in mind, these are going to be some of the more applicable things that we learn in this class, depending on what your major ends up being or what you end up doing with your life. But these are just kind of neat to think about. So if you look at the information that you have here, I want to talk about why we're able to do what we're about to do. So kind of if you look at, the picture that you have here, you've got somebody looking down at a mirror that's looking back up to the top of this statue of this guy, Ray. So kind of with that, we know that this vertical line would be parallel to this vertical line, assuming that we're standing straight up. So with that being said, there's some information that we know automatically, right? We know that the horizontal ground is going to form a 90-degree angle with our person. And we know that the angle with which we're looking down at this mirror is going to mimic what we see for the other triangle here. So in other words, if we look at the information that we have, both of these two angles are both going to be 90 degrees, and we're looking down at that mirror with congruent angles as well. So with that being said, if we're trying to figure out how big this is, I can set up that x over 1.8, so vertical over vertical, would equal the horizontal over the horizontal. And then I can solve for how tall this statue actually is. And this is something that you could do. If you wanted to figure out how tall something was, you could stand outside of it with a mirror, and you could actually do an experiment to figure out how tall something is by making sure that when you look at the mirror, you see the top of that building or statue or whatever it is you're solving for. So this is kind of cool. And so if we take this information and we solve, we find that x is 3. So this statue is 3 meters tall. Another example we can do is using the shadow that something creates at a specific time of day. So depending on how artistic you are, you may want to make this super pretty, or you may just want to make it as basic as possible. However, we've got this tree is casting a shadow, and we have Brad who's casting a shadow. So we've got the tree and Brad. We've got them standing on the ground at the same time of day, and the shadow of the tree is 12 feet long, and the tree itself is 24 feet tall, whereas Brad is 6 feet tall, and we want to know how long his shadow is. So to do that, we could say the height of the tree over the height of Brad equals the length of the shadow over the length of the shadow. Now at this point, you can solve the same way we always do, and we're going to find that x is 3. So in other words, his shadow is 3 feet long. However, you could have also potentially noticed that all we're doing to get from here to here is we're dividing by 2, or applying a scale factor of 1/2. So we could have used that scale factor here to create that 3 as well. That should be a 1/2. So we can either apply a scale factor or we can apply a proportion. If two triangles are similar, the lengths of the first are 144, 128, and 112. The length of the smallest side of the other triangle is 280. So looking at this, my smallest side I've represented as right here. So this is going to be my smallest side here is 280. What is the length of the longest side? So my biggest number is 144. So this is going to be my biggest side. And then again, we're going to set up a proportion the same way we always do. 112 over 280 would equal 144 over x. Now remember, you could have a little bit of difference here in terms of how you set that up because of that proportionality theorem that says your means can be interchanged. We could have also said 112 over 144 equals 280 over x, and as long as we set that up exactly the same way between one figure and the other, we should still come out with the same answer. So 280 times 144 is going to end up being divided by 112. So we find out that the longest side is 360. They don't give us any units here, so I'm just going to say whatever they are. There's 360 of them. A 40-foot flagpole casts a 25-foot shadow. So we've got our flagpole here. We've got a shadow that's cast. And we want to find the shadow of a nearby building. So we've got our building, and we want to find out how long its shadow is. So we've got 40, 25, 200, and an unknown. So again, as long as I'm consistent with how I set this proportion up, there's a couple of different ways. So I could say 40 over 25, so height over shadow equals height over shadow. Or I could say height over height equals shadow over shadow, etc. So just be consistent with how you set these up. So 25 times 200 is going to end up being divided by 40. So x is 125 feet. It's a big shadow. Now, I would put a star by this one in your notes. This one is one we need to be careful with because we've got to make sure we identify the triangles that are inside of this picture. So we've got this smaller triangle here that's got 90 and 160. And then we've got this larger triangle that's got 90 and 360 put together. So if I add those together, I end up with 450. And what I'm trying to figure out is how high the lamp post is. So this is my lamp post, my height. So when I set up my proportion, I might say 90 over 450 equals 160 over x. But be careful with that. The reason you can do this is because they have that shared angle here in the middle. And we're looking at what is that missing side length because these triangles are similar. So again, the reason for that, if this is vertical and this is vertical, I can safely assume that this angle is the same as this one. So this is secretly an angle-angle similarity problem in disguise. So with this one, I've got 160 times 450 is going to be divided by 90. So I end up with x being 800 centimeters. So the light, or the lamp post, is 400, goodness, the lamp post is 800 centimeters tall. Another shadow question here, I would recommend that you try this on your own and come back. Oops, I put my shadow distance in the wrong place here. So that shadow is 0.6 meters. And I'm looking for how high is the tower. So I might say x over 7, height over shadow, equals height over shadow. So 7 times 1.2 divided by 0.6 gives me 14 meters for the height. Then we have two triangles that are similar. I would recommend that you try this one on your own and come back to check as well. So the lengths of the first one are 40, 50, and 24. Again, this picture is just for me, so it's okay if it's not to scale. The longer triangle has 275 as its longest side, so my longest side here is 50, so 275 needs to go here. And it wants to know what is the perimeter of this larger triangle. So I'm looking for the perimeter. So this is one of those cases where I could set up several different proportions and solve. So I could figure out what is the length of this side, what is the length of this side, and then add them all together. Or I can total up the perimeter of the first figure, 40, plus 50 plus 24, and my perimeter is 114 for this guy. So 50 over 114, so side over perimeter, would equal my side over my perimeter. So 114 times 275 divided by 50 gives me a perimeter of 627 units. 2 more to go. A tree has a height of 4 meters and a shadow of 15. How high is another tree with a shadow of 20? Again, draw your picture, come back and check your final answer. So we've got one tree and another. We've got one that has a shadow of 15 and one that has a shadow of 20. So automatically I should know that this tree is going to be taller because its shadow is bigger. So I might say 4 over x equals 15 over 20. So I end up with 5 1/3 meters for the other tree. Again, when you get that 0.3 repeating, that's 1/3. 0.6 repeating is 2/3. So this is 5 1/3 meters tall. Last question, 2 triangles are similar. The perimeter of the first is 133. The length of 2 corresponding sides are 53 and 212. What is the perimeter of NOP? So I know the perimeter of the smaller is 133. So I might say perimeter of the smaller over perimeter of the bigger equals the length of the smaller figure over the length of the bigger figure. And then I can cross multiply and find that the perimeter of the bigger figure is 532 units. Thank you guys so much for your attention. Have a great day.